Hello everyone, welcome back to MidnightDevSec. In today's video, I will show you how to connect to a Kubernetes cluster, the one that we installed with MicroK8s on the VM on the previous video, and then we can look into some kubectl commands and how we can troubleshoot and amend some of the deployment that we did on the previous video and how we can understand better what this deployment is and how Kubernetes is managing it. So without further ado, let's jump into our editor, into our terminal, and see how we can do that. So on VS Code, we have two terminals. Left one is our local host, is my laptop where we're running VS Code, etc. On the right side, we have our banana user into our Ubuntu VM that runs MicroK8s. So if we jump into the VM and we do MicroK8s status, we can confirm that MicroK8s is running. We can even do MicroK8s kubectl get nodes, so we can see that it's running there on the latest version. Now, on the previous video, we talked about the kubectl config, which is the way that kubectl can connect to a given Kubernetes cluster. So let's see how we can get that to work with our local machine, connect into the VM or maybe the Raspberry Pi that you have installed Kubernetes, and see how we can manage that. So back on the VM, we can do MicroK8s config, and that will give us a reasonably big output. So let's copy that and put it into a single file and see what is in there. So if we do UR, we can have now a new file in VS Code. Excellent. So what we have again here is our clusters. And currently we have only one cluster, which is having a specific IP, and we can see what that is and what we need to do there. And then we have the context, which context is the context that we currently have in the config, and we have, and we have users. So Kubernetes comes with single user, which we can of course add more. The user is admin and it has certificate and key to connect to the cluster. So if we were to have this file saved in our local environment, then kubectl needs to know a way to use this file. So we can either export an environment variable that kubectl is expecting, or we can move this file into a directory that kubectl again is expecting. Now, kubectl is expecting the directory to be the kube in our home directory .kube, and then it's expecting this config to be in a file called config. Or we can export the kubeconfig to be the file that we're having, and that way kubectl will be looking into this file. The order of priority for kubectl is first is looking on the environment variable kubeconfig. If there is nothing there, it's going to look into the default directory, which is the .kube, and then it's going to look into the default file, which is config inside this directory on the home folder of the user that you're running the kubectl command. So we have exported now the kubeconfig. So kubectl will be looking into this file for information to connect to the cluster. So let's do that and see what might happen. So if we do kubectl get nodes, and we can see that it can connect directly. Now it happens that the server IP that I have here, it is also the IP of an interface that I have on the VM. What we need to change, in case you have that installed in a Raspberry Pi, let's say, or in a different computer in your house, we need to change this IP. So to demonstrate that, I can ping my local VM. So this is the IP, and I get to change it inside the config with a new IP. Then if we try to get nodes, we might get a certificate error. That's because the certificate that has been issued from the MicroK8s cluster is only applicable for specific IPs, for specific range of IPs, and the IP that we have put here is not one of them. What we can do is we can do get nodes, and we can say insecure skip TLS verify, and that will work. Or we can also go here and say insecure skip TLS verify true, and we can comment out the certificate, and that way it will also connect. So these are a couple of problems that you might see when you try to use a kubectl with a config from a different host using a different IP for your cluster. Okay, so let's revert this back to the IP that it was. So what we have now is a local kubectl on our local terminal can connect to our VM, to a Raspberry Pi, to our server on a given IP, assuming that there is connectivity between these two instances. And we can check every resource in Kubernetes, and we can. Okay, so previous time we deployed an Nginx deployment and an Nginx service in our cluster. We see how we can curl it, change some of the data. Today we're going to look into how we can manipulate and how we can change this deployment to scale it up and down. We can look into some of the Kubernetes resources involved into this process, and we can see how we can adjust some of the numbers that involve scaling the application, and we can look into how fast that happens. So we have in our files a deploy test.yaml, which again we have a deployment and we have a service. So let's go and apply that. We can see now there is a deployment created and a service created. We can go and get the deployment. We have one out of one, and if we go and get the service, we can see that we also have the Nginx service ready. Excellent. So let's go and describe and look into what resources this deployment has deployed. So the small resource in Kubernetes that we have is a pod, and we have the Nginx deployment pod. So if we were to copy the name and we do describe, excellent, the pod, and we're gonna paste the name of the pod, we get a reasonably big output. So let's look into this output and see what we have in there. So we describe the pod, we do get name and namespace of the pod, we get what node is running on, we get some labels which are very important to remember for one of the next resources, and we get annotations. So remember, the label is app equals Nginx, and there is a pod template which it has a hash number there as well. We can see the status of the deployment and the IP. The IP, it is one of the internal IPs based on the core DNS that we've seen earlier. We can also see that this pod is controlled by a replica set. And we can look into what a replica set is and how it's controlling a pod. We can see some of the containers inside this pod. Currently we have one Nginx container with the image and the image tag, etc., that we can see how we can play with it a bit later. And we can see all the standard notions, same as Docker compose or Docker command will have, of ports and volumes. And further down we can see the condition of the pod that is initialized and is ready. And scrolling even further down, we can see some of the events. So we can see that has been assigned to start, it has pulled the image and it has started correctly. So we said earlier that we have this pod, and this pod is controlled by a replica set. So the next question is, what is a replica set? So if we do get replica set, we can see we have one replica set there. And if we describe the replica set, we get an output. So what a replica set is the next resource up from a pod on how to control the pod's scalability, but also the pod's health. So if a pod fails, then Kubernetes will bring it back up. Kubernetes will have a way, which is the replica set, to say how many pods do I always need and how many pods will always be available and how many are there available currently. So how replica set is controlling that is based on a pod template. So replica set is going to look on any pod that has the specific labels, as we've seen earlier, app equals Nginx and pod templates equals 54b, etc. And is going to always bring a pod up. And there is a template for this pod. It has a specific image, specific port, etc. And it has specific replicas that is requiring this pod to be replicated as. So we have one desired and one current. We could have 100 desired and 50 current, because maybe 50 of them have failed, and we can see below that there's one running, no waiting, no succeeded, not failed. And we can see on the events that it successfully created the pod. Now we can see as well that this replica set is controlled by a deployment, which is the next resource up on the hierarchy. Let's now look into the deployment. So if we do kubectl get deployment, excellent, we get the Nginx deployment there, which is 1 out of 1 ready, it's up to date and it's fully available for 6 minutes. If we go and describe this deployment, we can see a very similar output to what we had on our Kubernetes manifest, our Kubernetes YAML file earlier. So we can see have a namespace, it has some annotations, it has a selector. What a selector is, a deployment will target a replica set, and the way to identify which replica set needs to be targeted, it will look on the labels of all the replica sets, and when these labels are fully matching to the selector of the deployment, it will control them and it will manipulate any of the numbers that needs to be changing. And it will instruct the replica set for any adjustments. So the current selector is app equals Nginx, which is the label of the replica set that we've seen earlier. We can see that this deployment has specific replicas assigned to them. So we have one desired, one updated, one total, one available. And that's because on the specification of the deployment, we said we want one replica. Then it has a strategy type, which is rolling update. One of the core differences between a replica set and a deployment is how these two are managing the pods on Kubernetes, on the Kubernetes cluster. We could have a replica set only and the pod, but if we need to update, let's say, the Nginx image, then a replica set will take all of the pods down and bring them all back up. So it will be a downtime between this while this process is taking place. The deployment on the other side has a strategy of how this is happening, and the strategy that is defaulting always is called rolling updates. And we can see that there is a rolling update strategy below of 25% max unavailable and 25% max search. So if we have 100 pods, then we would have 25 of them trying to go down and back up, and when they're ready, the next 25 will be assigned. This deployment also has a template, and we can see there are some events. Let's see now how we can scale this deployment. So let's go back into our YAML and go from 1 to 100. What that means is when we're going to reapply this YAML, the deployment will be updated, that now the replicas that we have here are desired to be 100. And we can see how many of them will be updated and how many of them are available. So if we do kubectl apply deploy, we can see that has now been configured. And if we describe again, we can see that 100 are desired, but 99 are unavailable, and one has been updated. And if we run that again, we can see 100 of them have been updated, 44 are available, and 56 are unavailable. So if we do kubectl get pods -w for wait, we can see live how Kubernetes manages all the different pods. We can see most of them are on running stage, and some of them have an image pulled back off. probably because of resources. And if we stop that and we get the pods again, we can see most of them are running. And if we get deployment, we can see that within seconds, about 45 seconds, we've gone from one pod in a VM that runs Kubernetes to 100 pods. So scalability in Kubernetes is the most important and most powerful thing. We can see how fast it will be to go back into 10. So again, we can go and apply. It's now configured, and we can go to pods -w, and we can see start terminating some of these pods, and it will take some seconds. And if we go to get the deployment again, we can see within seconds now it's down to 10 pods that are running on the Kubernetes cluster. So it's extremely fast, it's extremely easy to do it, and we can manage it on a single file. If I were to go, for example, and have a new version of Nginx, so we're gonna go from the Docker image Nginx latest into 126 to Alpine. How would we do that? Let's say it changes this. So we go back into our deployment YAML and we change the image into Nginx 126, etc. And on our terminal, we can apply the file again, and now it's configured, and we can get deployments. We can see 10 out of 10 already. Now 8 out of 10 already, because some of them have been changing. So remember the 25% strategy. Now 10 out of 10 already again. And let's have a look into one of these pods and see if they have been updated. So we can do get pods. So we have 10 out of 10 already. So if we do -o wide, we can see they're already running. And if we do this kubectl describe pods Nginx, and we're gonna pick one of them, and we can see a bit further up that now the image is Nginx 126 Alpine. So when it comes into upgrading your deployment and all the images, all the containers are running below, it's extremely easy. You update it on the YAML, and now you have a new version running on your cluster. What will be very interesting to look at is if we go to 100 and we apply that, we can see Kubernetes doing its job and is creating some containers. Sometimes it might fail because MicroK8s has limited resources. So while this is happening, let's have a coffee. So eventually, when this is going to finish rolling, it means that all the resources have been updated. We can also get deployment, and we can see 91 out of 100 are ready. And we can see the pods are still rolling, and remember the 25% rolling strategy. And now we have 100 out of 100 that are ready. Again, it took about 1 minute, 50 seconds, and we updated all these containers, all these pods. We created 100 pods from 10. So if we were to go now and change once again the version of Nginx back to latest, let's see how the deployment, we do a rolling update without causing any disruption, and how it will go and update all the pods. So we can get deployment and wait, and we can see 75 out of 100, which is a perfect example of how the rolling upgrade is working. And it's gonna keep rolling and rolling the deployments. And you can see on the column here, it says up to date 50. And we can see how this number is increasing slowly. And now we have 95 up to date, 100 up to date, and we can see how the numbers will start getting bigger and bigger. So what that means now is that 81, 85 out of 100 pods slowly updating. and this is not a linear updating progress, is different pods that are not updated to the specification of the deployment will be slowly updating, and now we have 100 out of 100. So this is it for today. We look into how to manage Kubernetes from our host. We look into how we can work with deployment and how we can scale up and down our application, a little bit of troubleshooting and a little bit of looking into it and looking into the hierarchy of Kubernetes resources from a pod to replica set to deployment, and how we can use those to scale our application but also to keep it in a reliable state of 100 pods, because why not? And on the next video we're gonna look into some more advanced concepts. We can look into the services and we can understand a little bit better how we can expose a Kubernetes pod into our network, how we can expose it and see into the internet, see how we can access that from a browser. I will see you on the next video. Thank you very much for watching.